and welcome. You should be on page 34 of your quarter 2 pre-algebra notebook. This is part 2 of our introduction to functions. In this video, we're going to talk about the vertical line test, and then we're going to do some intro to function review problems on page 35. So what is the vertical line test? The vertical line test is a way we can look at a graph and determine if a relation is a function. So the vertical line test is to determine if a graph is a function. And to be a function using the vertical line test, if a vertical line touches the graph only one time, the graph is a function. No, excuse me, not a function. So what is really useful when you're using the vertical line test is to have a ruler handy. So remember, a function is a relation in which every input, x, is paired with only one output, y. So there are no repeating x's. So I'm going to use this nice ruler here, and I'm going to have a vertical line on this graph number 7. And I can see using this vertical line that this graph on the vertical line hits the graph at this point and that point. It hits it twice on one vertical line. That means that this circle, or the graph of any circle, is not a function. Or we could just say it's a relation. Now, if I look at this is a parabola, and I can use my vertical line, and I can see that I'm only touching the graph one time. Any point that I'm on, right? There's no point where I'm touching it twice. So this parabola is actually a function. And if I look at number 9, right here, this vertical line, well, I mean, there are infinite points on the same vertical line, right? So there are definitely more than one point. It's not only one. So vertical lines are not functions ever, because as vertical lines, they definitely fail the vertical line test. So we're going to go over to page 35, and we're going to do some review problems. We're not going to do these coordinate plane ones. We're going to go right into, let's see, we're going to state the domain and range of each relation, and we're going to determine if it represents a function. I actually tend to like to determine if it represents a function right away. So I'm going to look at this set of ordered pairs, and I see that we have a -2, a -1, a 0, a 1, and a 2. All my x's are different, so this is a function. Now I'm going to list the domain, and remember, the domain is the list of x values in numerical order. I got -2, -1, 0, 1, 2. They're in numerical order as they're written, so I can list these right here. Alrighty, the range, I need to look at my y values and list those in numerical order. I've got -8, -1, 0, 1, and 8. These are also in numerical order, so I'm going to list them. -8, -1, 0, 1, and 8. Alrighty, let's look at 12, this mapping diagram. As I had said in the last video, I don't tend to love mapping diagrams, so I make them into table of values. It just works better for me visually. So I'm going to put my 3. 3 goes with -1. 4 actually also goes with -1. And 5 goes with -1. When I look at my x values, they're all different. So this is a function. When I list the domain, I'm listing my values of x in numerical order, 3, 4, 5. And when I list the range, I'm listing my y values, which are all the same, so I only list it once. And there's the range of that function. In number 13 and 14, I'm determining if these Graphs are a function, so I'm going to use my vertical line test. I'm just going to go right here at the y-axis, and I can see that this vertical line on the y-axis will hit this function twice. So this is not a function, or it's just a relation, right? This one, however, if I go here, it looks like it, but you can see it's going ever so slightly out, and it's an upside down parabola. And parabolas are indeed, this is a function. So the vertical line test will help me figure that out. 15, 16, and 17, let's think about independent, dependent variables. Remember, my independent variables are my x's and my dependents are my y's. So if I kind of look at all of these and I figure out it's always I got a coefficient with x. This is my independent variable, and my y is my dependent, because the value of y depends on whatever I put in here for x. Likewise, if I look like f equals negative 9.98 times a, f will be my dependent variable, because the value of f will depend on what I put in for a, and then multiply by negative 9.98. And finally, t, if I look at it, is my dependent variable, because the time equals whatever I put in here for hours and multiply by 10. So that's all for this video. Thanks so much. Bye.